It is so fantastic that you are with us tonight, ladies and gentlemen, as we go to lesson 3.4, page 104. And I'm here to tell you, if you understood yesterday's lesson on solving equations with addition and subtraction, then this one's going to be super dang darn easy. If not, this is going to reinforce and help you understand it, because we're doing the same darn thing, except instead of using addition and subtraction, we are using multiplication and division to solve equations. And of course, that will involve properties of equality. Our essential question: how can the multiplicative inverse be used to solve equations? Now, multiplicative inverse might be a new word for you. Please understand, it's the same exact thing as the additive inverse, with one small exception. Additive inverse, when you do the additive inverse of a number, what do you get? You get 0. That means you can use the identity property to say, hey, it's just x. Whereas the multiplicative inverse gives you 1, because when you multiply or divide by 1, you still get that same number, and that means the identity property is in play. So that's how it is used. Real quickly, equivalent equations, just a quick review. You know that equivalent equations are equations with the same solution. Let's talk about the multiplication property of equality that we're going to be using. And I bet you knew that before you even read it, that the multiplication property of equality says if you multiply both sides of an equation by the same number, that you get an equivalent equations. And algebraically, it said if A is equal to B, then A times C is equal to B times C. And if you use numbers, 7 is equal to 7. I believe so. If I multiply both sides by 3, then I know that 21 is equal to 21. I know it. And the division property of equality is the same thing. If I divide both sides by the same number, that it produces an equivalent equation. And they said that if A is equal to B, then A divided by C is equal to B divided by C. There's one thing they did add there, though. They said C cannot be 0. C cannot be 0. Another place you could put this is up here where it says dividing each side of an equation by the same. You could put non-zero, zero, the same non-zero. I gotta write this neatly, because I do expect you guys to write neatly, so I need to. Non-zero number. Okay? And please remember that you can also represent division using these fractional looking things with a... Wow, I'm telling you what, having troubles writing neatly all of a sudden. A divided by C is equal to B divided by C. And of course, numerically, if I have, let's say, 30 is equal to 30, and I divide both sides by 5, I would get 6 is equal to 6. Outstanding. Let's review our goals for solving equations. The first goal is to isolate the variable. That means use inverse operations. We're going to use multiplicative inverse operations to undo the given operation. We know that multiplication and division are inverse operations. Our second goal is to keep the equation balanced. We keep the equation balanced. We use those properties of equality that we just talked about. In other words, whatever you do to one side, you do to the other. So instantly in our brain, when we see we have to solve an equation, oh, I got to isolate using inverse, and I got to keep it balanced by doing the same thing to both sides. Bingo. Let's do it. Solving equations. So now, ladies and gentlemen, as you are watching this, I'm going to talk real fast and I'm going to write real fast. I highly, 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 highly recommend that you go one example at a time. You watch and listen. You don't write anything. You watch and listen to the first example. Then you pause the video and then you copy it down, repeating what I said in your head as you do it, as you copy the writing. That will take you what? 15, maybe 20 seconds. You're not going to add a ton of time to your notes tonight. Maybe a total of a minute to a minute and a half. Whoop-de-doo-dah. Is it worth it? It is. And you do that for all 4 of the examples we're going to do here. Because if you are just simply copying to get your notes filled out, you're not listening, you're not learning, and it's not good. Because this stuff seems pretty simple to some, it's pretty straightforward to many, but it's absolutely critical to when we get to more complicated equation solving later on. So please, follow my advice. Put your pens down, listen, watch, pause, then write, and start it up again. Here we go. Solving negative 5p is equal to negative 32. All right? So I say to myself, I'm multiplying my variable p. I'm multiplying it by a negative 5. The inverse of that is to divide by negative 5. So I come over here and I divide by negative 5. And I know that negative 5 divided by negative 5 is 1. So now I have 1p. And the multiplication property of the identity property of multiplication, the identity property of multiplication says if I multiply anything by 1, I'm going to get that thing. So just like what we were doing yesterday with the additive inverse, our multiplicative inverse gives us the identity property. So all we need to do is write the variable. We don't put a 1 in front of it. All right? So I did it to one side. Now I need to keep the equation balanced. I'm going to divide the other side by a negative 5. Too bad they don't come out evenly. It's not compatible, but that's the way it goes. So I could say that p is equal to a negative 6 2/5, or I could say negative 6.4. Either way you choose to write it, as long as you don't put that 1 on there before the p. Moving on. Example 2. 2/3 times y is equal to a negative 3 2/9. So I say to myself, I'm multiplying my variable y. Let me get a different color. I've been using the same color for a while. I'm multiplying y by 2/3. The inverse of that is to divide by 2/3. And I know we just finished our unit on rational numbers. Dividing by 2/3. I'm dividing by a fraction, so we're going to change it to multiplication by 3/2. We are. So I can do one of two things. I can multiply by 3/2. The 2's simplify out, the 3's simplify out. Or I can divide 2/3 by 2/3. Either way, I get 1, and I'm left with my variable. But over on the second side, I am going to go straight to multiplying by 3/2. So I'm going to say that negative 29/9 multiplied by 3/2. Now I'm going to grab my simplifier. 3 goes into 3 once, 3 goes into 9 3 times. And so I'm told that I have a negative 29/6. So my final answer is negative 4 5/6. Let's go on to example number 3. C divided by 8 is equal to negative 7. I recognize that my variable c is being divided by 8. My inverse operation is to multiply by 8. So I come over here and I multiply by 8. That's like multiplying by 8/1, which means those 8 simplify out, leaving me with c. And I do that to the other side to keep it balanced. Multiplying by 8, negative 7 times 8 is negative 56. Let's go to example 4. Notice I'm pausing to give you a time to stop the video and then write it all down and then start it up again. I hope you're listening. Our last example before we go to our quick write is x divided by a negative 5 is equal to a negative 4 3/5. I'm dividing our variable x by a negative 5. So to isolate, I need to multiply by a negative 5. That is the multiplicative inverse. So when I multiply x divided by 5 times a negative 5, the negative 5 simplify to 1, leaving me with x. And I come over here, and I'm going to multiply by a negative 5. So now I know my rules for multiplication. I have negative 23/5 times negative 5/1. The 5 simplify out. Negative times a negative is positive. That leaves me with 23/1. My final answer, 23. Your quick writes tonight. You have 2 parts to quick write 1, solving 2 equations. So go ahead and pause the video, copy them down, and then you can finish it out. Get a snack, get something to drink, talk to your mama again, tell her how much you love her, talk to your daddy, tell her how much you love him, and then come back and see us for video number 2.